Hi, welcome back. Last time, we did an initial overview of the engineering design process as a whole, and then briefly introduced the typical elements that it tends to involve. As we mentioned there, the first step tends to be defining the overall problem that you're looking to solve. And sometimes concurrent with this, or even as a subpart of this, is some background research necessary in order to have a sufficient understanding of the situation. Now, the problem definition step is something that novice engineering students can often be a little quick to dismiss. And there are a couple of reasons for this. Number one, that it's not always readily intuitive how many different possible ways there could be to frame a given problem. Oftentimes, a relatively simple, seemingly straightforward way of describing a given problem may seem to just occur to us, and it could almost feel like we're overcomplicating things unnecessarily to analyze that any further and question whether that's the right way to formulate the problem. And secondly, for most of us, it tends to frankly be a lot more fun to get into coming up with solutions. And so it takes some discipline to make sure that we give proper attention to some of these front-end stages that are every bit as critical. So we really need to make sure that we spend some time early on thinking about what is, in fact, the best way for us to formulate our problem before we let ourselves start to think about possible solutions. This is the slow to solve principle. It's based on the idea that at the front end of the overall process is where we tend to have the most flexibility for determining what general direction the rest of the process is going to go in. The farther we go along, the more costly in terms of time and resources that it can be to change course, particularly in a major way. Now, as we discussed last time, the process is heavily iterative. Sometimes those iterations include going all the way back to problem definition. But taking advantage of the unique flexibility that this initial stage gives us can really pay off in terms of making the overall process a lot more efficient. So hopefully, we hope that any revisions to the actual overall problem statement won't have to be too drastic. So then, how do we decide on the right way to define our problem? Well, first of all, let me just make a point that engineers tend to use the term problem kind of loosely in this sense. So, for example, there's plenty of products that bring positive changes that prior to their existence, the users and other stakeholders weren't necessarily seeking, but they nevertheless appreciate those improvements to our lives after they exist. So consider that problem can include a wide range of opportunities for benefit. The general approach that you take to defining your problem will depend in part on how much discretion that you have for how you approach the overall project. For example, in a lot of entrepreneurial situations, you may find that there's a lot of latitude to engage in problem discovery and origination. You're dealing with much more open-endedness than certain other situations where there may be constraints that come from a client or an employer, for example. But in any case, we need to really understand and truly appreciate that the way we choose to describe the overall problem we're looking to solve will have a tremendous impact on the range of potential solutions that we allow ourselves to consider later. As the economist Theodore Levitt put it, people don't want a quarter-inch drill, they want a quarter-inch hole. Now, we can, as a thought experiment, take this a little further and ask whether we're sure that a quarter-inch hole is even necessary. And that's useful, but in any given situation, we will reach our limit of how much potential discretion we have to rethink the overall context we're working in. The key is to make sure that it's an intentional choice to impose any limits on our framing of the problem, and that we're not just casually letting certain implicit assumptions seep into our thinking and unnecessarily constrain the range of possible solutions that we will allow ourselves to consider. This can be referred to as the broadest reasonable formulation of our problem. And again, there may well be situations where the broadest reasonable formulation is not nearly as flexible as it is in other situations. For example, if you're tasked with designing a new component for a certain system, and you don't have discretion to change the parameters of the overall system that your component has to work within, your latitude is going to be a lot narrower than if you were redesigning the overall system. And that's just one example of when there might be legitimate constraints that have to affect your framing of the problem. Just make sure that it's intentional and it's well thought out. That's the key here. Note that this kind of thinking also applies to a significant extent to various sorts of sub-problems that we'll also need to formulate at some point. This gets into a bit of a gray area. Gray areas are very common in this process, by the way, in the sense that it borders on what's usually a separate step of establishing specific design requirements. But the main point is that until we're ready to let ourselves start thinking about possible solutions, that's called the solution space, the range of all possible solutions that are available to us. Until we're ready to start thinking about that, we want to preserve as much flexibility for our future selves as possible by minimizing, for now at least, any expectation that particular means are necessarily involved with achieving particular ends. Now, yes, as you'll see, that line isn't always necessarily as clear as it might sound when I say it like that. And this is one of many judgment calls that you'll have to learn how to make. But like all of them, proficiency comes with experience. Something that applies to both framing the overall problem and to establishing the specific design requirements, which we'll be getting to in the next segment, something that applies to both of those is the need to consider the interests of a wide range of stakeholders, notably users and customers, but often many others as well. Talking with them can often be an important part of some of that background research that I mentioned earlier, particularly if you're designing something that you're not personally familiar with from a user's perspective, but often even then, because there may be a wide range of users. Having said that, at the same time, there is often a sort of tension to be delicately navigated there because people are sometimes not the best predictors of what they will want and what they would ultimately use and enjoy. Henry Ford famously reportedly said that if he had asked his customers what they wanted, they would have said faster horses. So ultimately, decisions like this are a combination of engineering and also business or strategic decisions that have to weigh a lot of factors. But this is just one of those broader context points that I think are good to keep in mind as you continue learning. So after you've decided how you want to state or define your overall problem on a general level, the next step is to flesh that out with a series of particular design requirements. That's what we'll look at next time. See you then.